Well, good evening, everybody, and thank you very much for coming, and especially thank you, David, for coming, because all those who I said would be speaking in your place, if you didn't, you could stand down now. Professor Sterling, ladies and gentlemen, good evening, and thank you for coming. Thank you, Professor Tim Green and Dr. Robert Gross of the Energy's Futures Lab here at Imperial for hosting this important lecture, the fifth in our series, inaugurated by Professor Sir Malcolm Grant in March 2014 at the Royal Institution of Great Britain. And thanks also due to Smithson Hill for your financial support in making this event financially viable. The University of Cambridge and Imperial College, London, are amongst the world's most important pioneering institutions in research and science and innovation. And in the absence of Professor Sir Leszek Borisovich, who unfortunately had to give his apologies this evening at the last moment, I have agreed, and I have taken the liberty of asking you, Professor Sterling, to take on the dual role on this occasion for a fleeting moment of representing the union of both Imperial and Cambridge, as you've had an equally distinguished career at Cambridge as an alumni and later head of the Cavendish Laboratory and as the Jacksonian Professor of Natural Philosophy. So I hope it's not too heavy a burden. Our two sponsors this evening represent in their own ways, significant aspects of the matrix that makes up the topic of this lecture. Dr. Gross's Centre for Energy Policy and Technology supports and promotes policy technology research through the Energy Futures Lab and is its director. The Energy Futures Lab is a cross-discipline institute to develop multidisciplinary cross-faculty collaborations to tackle the broad range of energy challenges that the world faces. Smithson Hill's project as a developer in Cambridge is Project UNA, the creation of a world-class agri-tech hub. This project will play a central role in supporting the ongoing growth of the globally significant life sciences cluster in the south of Cambridge. It is Smithson Hill's flagship project, and I'm grateful as ever to their managing director, Emma Fletcher, a past president of the Cambridge University Land Society, for their support. When I planned this lecture and invited Lord Willetts to give his paper, most of the world thought the UK was on its way to remain within the European Union. This lecture would probably have been that much easier to deliver, as Lord Willetts has been the undisputed champion and pioneering minister behind the coalition government's commitment to science and innovation in the UK, helping us take and maintain a world-leading position. Before the June referendum, the House of Lords Science Committee warned that substantial EU research funds now flowing into the UK were not likely to be covered by future governments if Britain left the Union. The committee stated in its report that the UK contributed nearly £4.3 billion for EU research projects from 2007 to 2013, but received nearly £7 billion over the same period. The excess was the equivalent to more than £300 million in research funds a year. You would be extremely trusting of the future Chancellor of the Exchequer to think that sort of funding will continue in the event of Brexit, said the Earl of Selborne, who was the co-chairman of the committee. We know the new Chancellor now has made a commitment about current project funding, but there is no medium to long-term commitment here to replace the EU funding. So we're in a period of extreme uncertainty and readjustment, and it is not a small issue. Anecdotally, we fund these lectures with substantial sponsorship, always. This one has been different, and it's most certainly not because of the quality of the speaker or the subject matter, but because of the referendum result. Prior to the referendum, there was considerable interest in sponsoring this event. After the referendum, American, Japanese and global companies have to a man said no, stating the uncertainty about Britain's future role outside the EU. So does this new environment affect the groundbreaking measures of the government over the last 6 years or more in setting up catapult technology centres, catalysts, launchpad competitions, the Research Partnership Investment Fund, university enterprise zones, and creating a vibrant, dynamic environment for further innovation and development? Let's hope not. We also need to be very sure that government support for innovation is contributing more to the economy than ever. As a recent Spotlight editorial reported in New Statement concludes, innovation has become harder and less effective because with each advance it becomes more complex. So tonight we concentrate on government policy, which is not just about funding. We need the right political and cultural policy leads for academic research institutions, individuals and businesses to contribute and develop. We have had a strong tradition in this country of welcoming immigrants who have made an enormous contribution, amongst many other things, to the development of science and innovation in a free-thinking, welcoming, socio-economic environment. We need to be able to maintain and not lose that advantage. A former government minister, then the Right Honourable David Willetts MP, not that long ago asked his successor in the House of Commons, then the Right Honourable Greg Clark MP, will the university's minister confirm that overseas students will continue to receive a warm welcome in this country? And will he assure me that we will not expect them to leave the country after they graduate and apply for a post-study work visa from abroad? The minister's reply was, "That is not government's policy, and I do not agree with the suggestion. I take great pride in the fact that the brightest and best people in the world want to come and study at our excellent universities." Ladies and gentlemen, that was the wrong answer, in my view, and continues to be a brain-dead policy. We need to change if we are to prosper, even more so now. There are about 22 professors and a large number of academic and research specialists from 8 universities here tonight. And so for someone who failed his 11+, it would be entirely inappropriate for me to launch into the subject of science and scientific research. Let me leave this to the man with a bigger brain or brains than me to do just that, the Right Honourable the Lord Willetts. David.
Well, thank you very much indeed for that generous introduction, and thank you for sparing the time to come here, especially after the Brexit referendum. Let me try. What I thought I'd try to do in this talk is tackle a kind of British problem that we are all familiar with, and here is an example from when it came on the agenda, I guess particularly during the First World War. The recognition that, particularly in Germany, science there has been more thoroughly and effectively applied to the solution of scientific problems bearing on trade and industry. A recognition that when it came to commercialisation or application of research, we seem to be less effective than we were doing the original upstream research. So, and there's a paradox here. The pure science, if you like, is protected by the Haldane principle, and on the other side there is a commercial marketplace where, by and large, there is an open and competitive environment which isn't controlled by the government. But there's that messy bit in between where there is, I believe, a role for government in helping science on its way to application and out into the market. Now, if David Edgerton were here, I don't think David is here, but if David, formerly of Imperial, were here, he would say the response to that analysis was that for 50 years there was what he very neatly called a warfare state in Britain, where there was a large amount of applied R&D from 1920 to 1970, and that is a fascinating historical point. But I think that statement has become true again of Britain, and became true of Britain again in the 70s and 80s after we abandoned that model. And I want to try to explain today my explanation as to what the problem is and how it can be tackled. It's not insuperable, and indeed there have been lots of excellent initiatives over decades to try to do something about it. And my explanation rests on this. It's not culture, it is three specific features, three tensions in the way in which we fund and organise science and its application in the UK, which help to explain our problem. And in the bulk of my talk, what I would like to do is just to take you through each one of these doctrines, dilemmas, whatever you want to call them, in a bit more detail. Let's start with what many of the professional academics in the room will recognise as the dual funding model. And we are very proud of the dual funding model. We regard the dual funding model as one of the great features of British research funding. And it means that out of the science budget, which doesn't just cover sciences in the traditional sense, it's a research budget, includes the humanities and social sciences, the bulk of the budget is allocated in two ways. Research Council funding, which tends to be for projects and programmes, and secondly, HEFGI, funding from HEFGI for universities based on increasing on their performance in research. Now, I'm caricaturing both of those flows, but there is, I think, it is a recognisable characterisation. Project funding from the Research Council, institutional funding from HEFGI, which was initially envisaged explicitly as an alternative to having an endowment, but is itself, you could argue, has increasingly become based on immediate performance, less patient than it was. Now, the fact that we're so proud of this dual funding model, I think, has obscured the fact that it has a significant omission, which is no high trust funding outside universities. Or to be fair to the research councils, they can run research institutes out of their budget, but the pressures on their budget have tended to mean that the research councils would rather run projects and programs than fund institutes. There's a perpetual pressure on them to shrink the institute budget. And indeed, the philosophy of many of the research councils is that they don't want to have long-run institutes that they're obliged to carry on funding regardless of the quality of their research. They pride themselves on the fact they're always looking around for the smart new performer. Nobody can presume that they will get funded in the future just because they've been funded in the past. So, hidden behind the dual funding, there is a gap. That's my first dilemma, therefore, that despite dual funding sounding as if it covers all the options, I think it leaves a significant gap behind. The second dilemma, it was captured in one of the most vivid reports that have been written about British R&D policy over the decades. One reason it was so vividly written is it wasn't written for publication. They only decided after Victor Rothschild had written his report that perhaps they should publish it because it was starting to leak out. And he famously introduced the customer-contractor model of applied research funding. He said that if you're going to have applied research, you need someone who is purchasing it, and he identified individual government departments as the purchasers of applied research, and treated it as very different from basic or fundamental research, which would be the responsibility of the research councils and the science budget. In fact, what he was actually doing is recreating the Haldane model. This was how Haldane had originally described the ideal system back in 1918, with a science budget where there was very limited political intervention, doing upstream research without political control, and separately departments that needed research to carry out their functions, being the purchasers of applied research. Now, there is an interesting debate about whether you can really separate out applied research, but that was the model, and the idea was that if you want work on social mobility, the Department for Education should be funding research on social mobility. If you want investment in agricultural practices that will boost the performance of the agricultural sector, that would be for MAF to fund. And after Rothschild, his model was applied. And I literally had conversations when I arrived as the science minister in 2010 from people in research councils who said, whatever happened to our research money? So there was a transfer of funding from research councils to departments, so they could be custodians of applied R&D, but departments then proved to be very poor protectors of their own R&D budgets. Over the decades, those departmental R&D budgets were cut and cut and cut. They were like the worst of British business. Whenever there was funding pressures, the first thing you cut is the R&D function. So you have the customer for the the customer who's supposed to be purchasing R&D regularly cutting their budget, leaving behind only the science budget, which has a different model, which is protected behind the Haldane principle, because that's not really supposed to be for the applied stuff. The applied stuff is supposed to be departmental. So, now, this... I've inserted in the middle a quote from Rothschild, simply out of a spirit of mischief. It is, for those of you who are following closely the debates about UKRI, may think that that is relevant to today's debates. That was the idea that was knocking around at the time. Should you merge the research councils, or should you put some body above them that would act as the executive agency between the minister and the research councils? And that's what Rothschild said. A different view has been reached. Now, going on with the narrative, what happens to the department as customers? So the departments prove to be poor customers. Their budget's cut. And I think when you then look at what happened under Margaret Thatcher, influenced by Rothschild, the minister, incidentally, who received Rothschild was, of course, Margaret Thatcher, who was then Secretary of State for Education and Science. What happened in the 1980s was the Rothschild doctrine that applied research requires a customer was then transformed and developed and became, and the customer is business. Businesses should be buying applied research. The departmental budget was cut. Near market research is the responsibility of business. And all that government should be doing is the upstream scientific research from the science budget. So the company gets redefined as the customer, as departmental R&D budgets fall. Now, that means that the idea of two separate ways of funding research, a upstream science budget and applied research spending held by departments, that latter function is eroded over decades, and you end up only with a science budget. And incidentally then, I was very aware of this, endless pressure on the science budget, on the science minister to tweak it a bit. Please, could you help use it for applied R&D purposes? So, and that became, and then at that point people start understandably getting worried about Haldane principle. The most vivid example of this is agriculture, which is a good example because Rothschild himself had previously been the chairman of the Agricultural Research Council, where the agriculture, the MAF R&D budget was cut over decades to close to zero. And you could then track the lag. You see, Britain used to be a world leader in performance in agriculture, continued improvements in agricultural productivity. Improvements in agricultural productivity in the UK in the last decade have been close to zero. And investment in applied R&D in agriculture has been close to zero. And we set up the agri-tech strategy to try to reverse that. So the second doctrine is the idea that there is pure research and applied research. Departments should be the custodians of applied research, and they fail to discharge that responsibility. Then it becomes companies should be the custodians of that research, but that leaves a massive gap between the pure science that is publicly funded and the kind of applied, immediately valuable R&D that companies are willing to pay for. That's the second feature. My third feature is something that in Whitehall is of massive significance, but is rarely appreciated outside. In Britain, universities are private sector institutions. there are parts of Europe where they're not. They're part of the public sector. I had long conversations with academics who wanted to emphasise the public value of the university, and the university certainly does have a public value, and then they would say we carry out a public service. When I said to them, so would you like to be in the public sector? When the implications of being in the public sector dawned, they were not so keen on the idea, so that you would have public sector pay rates, your borrowings would count towards the PSBR and all that. The universities are in the private sector. Those research establishments which have survived the other two doctrines, there's a small number of public sector research establishments which survive, some of them owned and operated by research councils, some owned and operated by departments, are within the public sector. Now, some of them do survive, many fewer than we used to have, and they fulfill a very important range of functions, which is not the same as doing brilliant upstream research. The British Geological Survey is a fantastic resource keeping geological samples drilled. Any geological sample that has been drilled anywhere in the UK, some of it has to be deposited at the BGS. They have it's a kind of filing system, and they have the most extraordinary filing cabinets I've ever seen, filing cabinets that can each, I think, hold 10,000 tonnes of rock. They are essentially the nation's filing store for its geological samples. The National Physical Laboratory in West London, custodian of measurement and standards. Laboratory of Molecular Biology, interesting, at Cambridge, doing multidisciplinary research. It doesn't completely match the structures of departments within a university. So these are public sector research establishments. We used to have a lot of them, and in the post-war period, they have steadily been reduced. And my argument is that you need these type of intermediate bodies that aren't university-based, but may be accessible or of use to business and industry and a source of applied research, but they have found it hard because they're in the public sector. And for me, having worked both as a civil servant originally and then in the department, it is frustrating to say this, but its life is very tough if you're a public sector research establishment. You have public sector rules on pay, in contrast to the universities who might also be recruiting in the same talent pool. So you will find that public sector pay rules apply, but the university down the road can participate in an international competitive market for researchers where you are inhibited. Some departments just don't seem to be particularly interested in what they've got. Department of Energy. Some of them have a wholesale policy of privatising them. In agriculture, a lot were privatised in the 1980s and 1990s. And incidentally, another reason why we have a relatively limited ecosystem of these types of public sector research establishments is that they also used to be run, a lot of them, by nationalised industries. And I would plead guilty on this. I was in the Treasury when we embarked on privatisation in the 1980s. I can't remember any significant meeting with a minister when we were working out how to privatise and nationalise industry when someone said, we've got to preserve this R&D function. They do incredibly important R&D. And what was, or had been historically often quite an important source of R&D, was lost out as a result of privatisation. And because of the model that we're paying for stuff, we're not paying to keep institutions going. Very powerful report from the House of Lords on nuclear, how we handle the nuclear industry, which came out about 5 years ago, which said basically there hadn't been for over a decade any investment in core capacity. Nobody had said we need a national nuclear lab that is just there to be a source of expertise on nuclear lab. There was a very small one that had survived, but only by virtue of getting project funding. Only funded from project to project. And as I say, I think this is a poor reflection on public policy in Britain, but essentially, whereas other countries seem to find it possible to maintain and indeed grow their network of departmental research labs, look at what America has got with its Department of Energy, so even before you get to the Department of Defence. In a moment I'll show you the German network. In Britain, being a research establishment in the public sector has proved to be very tough indeed. And I brought in something called the Manchester Guidelines, which was a last-ditch attempt. It goes back to a piece of work that Manchester University did for it, which was a last-ditch attempt to actually try to at least introduce a decision rule before another one was closed down or privatised, saying, have you checked, does it carry out a core function that may be necessary in the public sector? And then Mark Walpole is similarly exercised. We hadn't even got a taxonomy, we hadn't even got a proper list of what all these were and the means of protecting them. And Biz didn't have a body that could protect them. When we had any of these agencies that Biz were running, we ended up asking the Homes and Communities Agency, who wouldn't mind being the landlord, to look after these places. So the public sector proved a very poor protector of research establishments. So they all look to the safe haven of moving over to a university. The best thing that you can do is find a way of being embraced by a university when you miraculously become part of the private sector. And it looks as if all your problems have been solved. You're no longer subject to all these TAS and public sector rules. The universities say they'll look after you, but of course universities change their policies. A new vice-chancellor comes in and isn't interested in something. The sexy research topic is something different. They can go into universities and it looks like a good deal for the first 5 years, but they don't necessarily survive in the long run in the university environment. Now, those three factors, I think, have been very important, therefore, in shaping the British environment. And just to remind you that, firstly, no funding for public sector research establishments doesn't really fit neatly into the dual funding formula. No applied R&D budget, because that's what departments are supposed to do, and over the years they've cut it back. And a tough existence for those PSREs that have survived, a tough environment in the public sector with private status in a university looking far more attractive. Compare that with Germany, and you will all be familiar with a network of research establishments in Germany. And that German alternative, I would argue, is a more industry-friendly way of organising your research. It's not the only way of organising your research, and it shouldn't be, you shouldn't have all your eggs in one basket. But if you are working in a specific branch of German industry, you are very likely to know a prominent, big-name research establishment, Fraunhofer or Helmholtz probably, that is doing work that is relevant to you. And it's probably been around for decades, and it is accessible to you. Those, of course, are not universities, and that means that Germany's research effort doesn't help its universities rise up the research rankings. So in all the conventional global measures, Germany looks like an underperformer compared with the UK. But we do well because we've got all our eggs in the university basket, and that's what the rankings look at, universities and their research performance. And we've ended up with a very unusual pattern of R&D activity in the UK as a result of this. And here are two different ways in which you can slice these figures. This is, HE R&D is R&D funded and carried out within higher education, as distinct from other forms of R&D, which could be in public institutions that aren't higher education institutions, or could be commercial. And what you see is that so here we are. The percentage of all R&D that happens in higher education institutions, 13% Japan, 14% US, 17% Germany, 26% UK. So we had, out of all the cross-economy R&D activity, we've got much more happening in universities than most major Western countries. So it's interesting. I mean, the Baltics have got even more. And another way of really looking at the same figures, let's look at R&D spend as a percentage of GDP, where sadly we are below the major Western competitors. But look, we are significantly lower on business R&D. We're much, much lower on government R&D, but we're just about respectable on HE R&D. So what we've done is we have ended up with a strategy where we do well on HE R&D, but far worse on the other main ways of doing R&D. And my argument is that that pattern of R&D spend in the UK is what makes applied research, technology, commercialisation harder to do. It's not because universities are bad places and they often use their best efforts, especially nowadays, to try to overcome these barriers. But it is an unusual, we are an outlier in the way in which our research is distributed. And so what are the features of our model? What do we get for our model? We first of all we score very highly on autonomy. A very large amount of our research is conducted in institutions or in the private sector that should not be micromanaged from Whitehall. So we have, with relatively little public spend directly going on R&D on a customer contractor basis, and most of the public money going into universities that are in the private sector, you score very highly on autonomy, which is very good for extremely creative scientific research of a certain sort. I would argue that because we have a very thin ecosystem of research establishments outside universities, that is one reason why applied research is harder to do. The fact that we have so much of our research in our universities, and there is not really any other place where you could do a very, on scale, a large amount of R&D, that's incredibly good for our universities in the rankings, compared with other countries, where the universities are a smaller player in the overall R&D space. So when you're looking at rankings that are university oriented, they look good. But it may be bad for innovation. That is a British model which is emerged as a result of policy decisions in the post-war period. There isn't some kind of cultural problem that we're risk averse or something. This is rational behaviour given the set of incentives and institutional arrangements that we have now got in this country. Now, we need to have time for questions, and I'm going to turn in a moment to the kind of policies that help tackle this. There are ways forward, and successive governments, going back to David Sainsbury, I think, have recognised this issue and done things about it. But I guess as which stage of grief on Brexit you guys are in, but we better just pause. It would be irresponsible to turn up here and not talk about where we are on Brexit. Funding, I should just explain what I'm saying there. I mean, on Brexit, we've got to be, I think, and I know that this debate is going on in universities, I think it was quite salutary the way the referendum went. Here you had such a clear view from the vast majority of people in higher education and research that it was massively in Britain's national interest to remain members of the EU, and the vote went the other way, which does show that what universities and the science community think may not have as much impact on the wider public as people in universities and research would hope. And when you look into the detail, it's interesting. I think it's striking when you look at this fantastic return we get on Horizon 2020. The fantastic return we get on Horizon 2020 is university research, absolutely ties in with my earlier argument. We are not so good at businesses getting a lot of Horizon 2020 funding. Our business performance is really rather mediocre. It's our university access to Horizon 2020 that's significant. So in other words, this case for we need to be part of Europe in order to strengthen our R&D was very much a university argument. You were not hearing it from a large, vociferous business community that said, we use these programs because they're really important for our R&D. Also, the argument, looking back with the wisdom of hindsight, was presented very much in financial terms. We get lots of money out of Europe, which of course enabled the Brexiteers, who argued Britain was a net contributor to the budget, to say, well, we can use the savings on their net contributions to the budget to plug any funding gaps. When increasingly it's clear that the networks that you get from being part of the EU are as important as the funding. And there's in fact we had a debate on this in the Lords today. I know there are ministers who think we shouldn't be in Horizon 2020 post-Brexit because it's expensive and administratively cumbersome and clunky. That may be a feature of what you have to be like when you're trying to link institutions in multiple countries, but in which case you've got to make that argument. The mood in government is very much we've got to look forward and think of opportunities. One opportunity is that the EU regulations in various sectors I found completely frustrating. I would argue with my colleagues about, and there are people here who know the list as well as me, GMOs, the regulation on data, big data would be another example, French antitrust and nanotech, the Rousselet judgment and cell therapies. So there is a scenario in which we break free from all that regulation and do innovative science and development that isn't possible within the EU. However, if so, what access would we then have to the single market? And so and I've been going through this thought process myself. You say, well, we're going to have a more liberal regime on data than the EU, so people will come to Britain to do data science. The EU would be completely understandable for the EU to say, well, we were going to have regulations that say the data about EU citizens has to be stored in places that comply with EU regulations. And the big server systems move across to be within the EU and comply with EU regulations. And then people start writing the software that enables you to operate the systems that comply with EU regulations. And before you know where you are, we've become we're a kind of, our software and our apps are the ones that you get after the Americans have got theirs and after the EU has got theirs. So it's not straightforward, this option of breaking free for innovation. It's a classic example of the kind of policy dilemma where the more open debate we have at the moment, the better. A guilty secret about venture capital. I'm trying to set up a venture capital fund myself at the moment. And I can remember the figures that we had in biz. There was 1 year, I think immediately after the financial crash, Peter Mandelson's final year in biz, and I don't blame him for this, when the statistics for funding going into venture capital showed, if I remember correctly, 58% of all funding going into venture capital was public money. We were socialising VC funding. And as well as being, and it's fallen a bit since then, not as much as you might expect, the other guilty secret of venture capital is how much of it is Europeanised. How much of the venture capital that these bright, dynamic entrepreneurs are doing actually is originally soft European money from the EIB and related programs. I've seen estimates that 25% of all flows of funding into London-based VC are currently EU funds. So that's the kind of angle you start thinking, well, how are we going to fund that post-Brexit? And because we are all urged not to just get into a state of deep depression, and there are always some things you can tweet. One message I've been putting to all my friends, I think is going to get through, is that we all know the frustrations of the VAT rules, that if you have a commercialisation, innovation unit alongside a new build on a university campus or in a public sector research establishment, you will be told that can only be 5% of the activities that happen. If it's more than 5% commercial activities, the whole cost of the building will become vatable. So that's a kind of tiresome feature of the system that could change with the freedoms post-Brexit. So there we go. So but you may want to we can talk about that further as we get into discussion. The last part of my talk, I just want to analyse, in the light of the analysis I've offered, just look through the kind of things that you can do in order to promote innovation and applied technology in this environment. And clearly, they kind of conceptually, there are two categories. One is the kind of things you can do with universities, given that that's where a hell of a lot of the R&D happens, and a lot of universities are completely up for this. Even it's happening in universities. What more can we do to promote commercial and applied tech in the university environment? And the other thing is, to what extent can we create a richer ecosystem with funding streams and institutional arrangements that promote commercialization outside the university environment? And here are some examples. I think spin-outs are overrated. I think too many fragile, non-viable entities get spun out early on and have a sort of existence where nobody quite puts them out of their misery, but they can't even necessarily afford to protect their own patents. Spin-outs have become the metric of commercialisation for universities, and I don't think it's a particularly strong metric. There are many other forms of university business links, including with larger companies and doing research programs on contract. I'm a member of the board now of the National Council of Universities and Business, and we are setting up something that I urged him to do when I was a minister, which is simply an accessible database, which we're calling Confer, of every publicly funded research project going on in Britain. So if you're an engineering company that suddenly finds yourself dealing with a new metal or a new alloy that you haven't come across before, you want at least to be able to Google it and find if there is a place in Britain, probably a university, where the materials science department is doing research on that metal or alloy. Amazingly, that was not a searchable database that was accessible. Confer, which we are developing, enables that to be done. Minimal things like that. Innovate is incredibly important. David Sainsbury's creation, which is called TSB, deliberately aimed to help plug the funding gap. So fund innovation and applied research to match all the funding going into science for upstream research. And I think it's very important that they have grants in their locker, not just loans. And I very much hope that we'll see a rebalancing of their budget back towards grants after the experiment with the loans model. Other ways in which you can link upstream and downstream, I think we can learn from life sciences. In some ways, I wish because there's a limit how much reorganise any system can take, and I'm not a great fan of reorganising things. Imagine if instead of creating UKRI, we'd taken the Oscar model and applied that in some other key disciplines and sectors, which is the obvious strategic coordination of research in life sciences, which essentially provides a framework in which the Medical Research Council and the NHS and the MOD are the only two departments with a surviving significant R&D budget come together. And models like the biomedical catalyst, and it's excellent that the Chancellor has found further money for the biomedical catalyst, linking MRC funding and Innovate UK funding, so that a person working in the lab can see a route from the lab to the marketplace. So there are ways in which you can try to overcome these barriers, and as I said, we're really keen on a stronger network of research institutes. This was the thinking behind the catapults. They were absolutely modelled on the Fraunhofers. When my party was in opposition, we commissioned James Dyson to do research on this. At the same time, Peter Mandelson commissioned Hermann Hauser to look at the issue. And these two parallel reports, both coming out in 2009, had very similar solutions that we needed something like a German network of Fraunhofers, and that's roughly what the catapults are. An attempt, instead of seeing this ecosystem endlessly shrinking and thinning out, to create some more intermediate institutions, publicly funded and privately funded, doing applied R&D, and outside the university environment. And then, of course, industrial strategy, which has waxed and waned, and it's good to see industrial strategy back. I think that Vince Cable and I went through a very similar thought process as we developed our industrial strategy. It rather fell out of fashion, and it's now back in fashion. There are different ways in which you can do it. You can focus on business sectors, tending to be Vince's approach, and you can understand these big sectors, aerospace, automotive, benefit from the attention of government. You can focus on places, which was very much George Osborne's interest, and I think is probably my friend Greg Clark's interest. How do we turn this to promote the revival of cities and city regions? You can focus on challenges, which was the number 10 angle. They always wanted Alzheimer's. We must have a fund, or antimicrobial resistance. We must have a challenge fund to get the best ideas to tackle those challenges. And my personal interest was technologies. Now, it was a bit confusing with different players with a different agenda. So if you're trying to make sense of industrial strategy as it's developed in Britain in the last 5 years, you have to have all those 4 kind of dimensions. But I would argue that, oddly enough, it didn't turn out too badly. And from my perspective, focusing on technologies, they were inherently disruptive, and they were, and the 8 great technologies that I identified, and there are people here. I see Professor Richard Kitney, who was crucial in developing our strategy for synthetic biology. The 8 great technologies wasn't a matter of sort of personal whim. This was drawing on the expert advice of areas of science and technology where Britain had a strong research lead, where there was a business opportunity on a global scale, and where some public funding could help promote these technologies. I had both some dry technologies, data, robotics, space, wet, biological sciences, and then advanced materials and energy storage. And although these kind of frameworks need to be refreshed, equally you don't want to turn them up and start all over again. And I've been having interesting conversations just in the last few days as a new industrial strategy is being developed about some of those very technological areas. And then finally, if you are trying to be a minister delivering an industrial strategy and promote that commercialisation, the application of technology, what's the sort of micro decisions? What are the things you can do to help make this happen? And this was my shortened version of a list I put into Prospect a month or 2 back, which for my successors on just none of them massively exciting on their own right. But if you put all those things together, I argue for a sector or a technology, these become the practical bricks that enable you to run an industrial strategy to promote an advanced technology, for example. A leadership council, just using convening power, where you bring together around the same table academic researchers and business users or business spenders in R&D. Often find an expert or a group of experts that you can commission then to write a technology roadmap, which is partly just a description of where the R&D budgets of the main business players are currently going, where the research councils or other public funders are putting their money in R&D, and you suddenly find areas of overlap, gaps. You suddenly find you start having a conversation where people say, well, for 20 million we could do this technology. If government puts in 10 million, perhaps this gap might be plugged with 10 million of private spending alongside. So although these things, you don't have perfect foresight, can be very useful exercises. Although regulations can be a bad thing, when it comes to new technologies, new regulations can be a good thing. They can be the precondition for spreading access to technology. It's the precondition for their becoming globally significant. And often one of the many advantages that we get from the quality of our science and research in Britain is we've got people at the cutting edge who can help influence regulations across Europe or globally. Take a lead in promoting some innovative standards for new technology. So you, as a minimum, get a place at the table when the standards are being written at a larger scale. Funding awards, especially for those innovative startups who haven't got funding for proof of concept, proof of market, that can be useful. Smart procurement, which is one of our great frustrations, people being willing to buy new technologies rather than playing safe. A number of conferences or meetings one's been at where the American entrepreneur, when you ask how he or she is funding their company, will say, when it's at a highly speculative stage, they will say, well, I've sold the first 20,000 of my widgets to the Department of Defense. And you'll say, well, you haven't made a widget yet. No, but they realise that if I can make a widget, it could be just possibly of value for the armed services. So they've written a cheque for the first 20,000, and I'm spending it developing the widget. Non-dilutive finance, which they all love. And basically, because American technology strategies, there should be no significant technology anywhere in the world where the US is not up there in the lead. And sometimes these guys will develop their 20,000 widgets, sometimes they won't. But there's not a terrible scandal when it proves that that widget doesn't work. It was nevertheless, there's a widespread consensus in the US. It's the kind of thing that federal money should fund. Skill shortages, stands to reason, but again, you can get specific conversations going, which literally start being, if we put a bit of funding in to these education institutions in this region and it boosts your supply of people who are good at computer science or understand tunnelling engineering, that would help. The launchpad competitions that Innovate UK launched that helped clusters, help promote innovation within geographically defined clusters, and also pitching to overseas investment. So, I've tried to explain to you what seemed to me to be the crucial drivers of a British problem that we don't always commercialise and apply some of the great ideas emerging from our science base. It's not because there are bad people or we're cautious people or we somehow have some cultural or genetic problem. And it's certainly not that there are bad people in universities, and universities should do better. Universities, compared with universities almost anywhere else in the world, do more to promote innovation. But then they need to, because our British strategy, as it has emerged, has ended up with many more of our eggs in that particular basket than in most other advanced Western countries. And my conclusion, wrestling with these dilemmas as a minister, was a real challenge, was to refresh and extend a network, both a funding network and an institutional network that supported R&D outside a university environment alongside what happened within universities as well. Thank you very much indeed.
So as a computer scientist, I know exactly how to work with technology. There's be a benefit to being one of those.
There. There.
So all my training was not entirely wasted. I do know how to drive PowerPoint. So my name is Nick Jennings, and I'm the Vice Provost here for Research, and I've been delighted to welcome you all this evening to Imperial College and to thank David for a most excellent and timely lecture. Many of David's comments about being in government are absolutely something I recognised. I was the government's Chief Scientific Advisor for National Security for 6 years, so from 2000 to the beginning of this year. And I so recognise so many of the points that you made. So some excellent points around expertise of staff within government. Civil servants are amazing at what they do. They're amazingly dexterous at picking up new briefs, but sort of deep expertise is not something that you typically associate with civil servants. I also recognise the point about pay as a civil servant as well. It's a very different pay scales to universities. I think sort of the lecture was really very insightful. I thought it was an excellent analysis of the landscape, the funding landscape, and I think it really takes us on from what I think are quite lazy assumptions that we're not very good at innovation or we somehow lack courage to do it, and sort of really trying to put forward some ideas and some analysis and some data as to why we have an ecosystem like we do. I thought was really insightful and exactly the kind of debate that we need to be having. I think your point also about Brexit and the deep depression is again something that as universities and the science sector is really something also that we need to move beyond. There are opportunities there. We need to be able to make sure that we're able to factor and respond to what political situation we will end up with, and really to make the most of it. We can't just stay in deep depression and wish it would go away. There will be opportunities, there will be things that we can do. It is a lot about the networks, and I think that's something that we're really keen and working with government to really make that message. The money is important, but also so is that network and connectivity. And then sort of the view of some of the ways in which we can reorganise our system, some of the things that we can do. So some quite simple things, I think, that are just, you think that seems a common sense way of doing it, but as that package of really putting together a whole variety of means and mechanisms to help us address and really help us tackle this problem is really insightful and a a great place from which to start and carry on with these particular debates. So I would like to thank a couple of other people as well, the Cambridge Whitehall Group, the Cambridge Land Society, the Smithson Hill, and also our own Energy Futures Labs for being involved in this. So can you please join me in thanking David Willetts.